Hello everyone, this is Srimano and welcome to Genius Math Minds. In this video, we will see the types of sets. We have a lot of sets here, we have a lot of types of sets here. These will be very helpful because you can determine what kind of a set it is just by looking at the elements. So that's what this is. So we have finite and infinite sets, empty and singleton sets, equal and equivalent sets, subsets, proper subsets and power sets. Now these two will be very helpful, subsets and power sets, because they will be useful in various other kinds of problems involving sets too. So that's why these two are really helpful, are really important. So first, finite and infinite sets. So as the name implies, let's say we have a set like A, E, I and O, U. Let's say A is the set of all vowels in an English alphabet. So this is a finite set. Why? Because we can calculate the n of A as 5. Now this 5 is a countable number, or it is a number. We can count the elements of this and we can get the value of a whole number. That is 5. Let's say we have another set B, which does not have any elements. Now n of B is equal to 0. We can count the elements in this set too. Since the number of elements in a set is finite, it is a finite set. It is called a finite set. So that's finite set. Now infinite set is the opposite of that. Let's say we have a set that contains all integers. Let's say this is the set we are dealing with. Now how many integers are there? There are infinite number of integers. So if we put a set like this, then we have to do. So this is how we will write this set. Can we count the number of elements in this set? Yes, but it is infinity. So n of A, so the number of elements in A is infinite. We cannot count each element and we can get to a final value or a whole number. So that's why it is an infinite set. So now empty and singleton set. Now as we have discussed with finite sets, this is an empty set. Now this can also be denoted as this symbol. So this also denotes an empty set. So this is an empty set. Let's say we have a set that represents x square plus 1 equal to 0. That let's say we have a set A, which is the answer for all the values of x that is in integers. Can we get that? No. The only value of that is I, which is imaginary. So we cannot have any solution to this equation, which is an integer. So it is an empty set. Or we can write as null set. Empty set is otherwise called as null set. So this is what we have. So if a set has no elements, then n of A equal to 0, it is an empty set. So now a singleton set is similar to that. That is, it has only one element in the set. Let's say we have a set S. Let's say it contains all the even prime numbers. So how many elements can it have? It can have only one element, that is 2. Because 2 is the only even prime number. So the number of elements in S is 1. So if the number of elements in a set is 1, then it is a singleton set. Now we have to be careful. So what is this set called? Is it an empty set or a singleton set? So this is a singleton set because it has one element. That is, the 0 is that element. So this is actually a singleton set. So now the next thing is, what is equal and equivalent sets? Now these involve two sets, A and B. Let's say we have a set 1, 2 and 3. And another set 1, 2 and 3. Now these two are equal sets. How? Because n of A is equal to n of B. This is one condition we need to check. And we also have to check if each elements are the same. So we have 1 here, 2 here, 2 here, 3 here and 3 here. Since all the elements are the same and n of A is equal to n of B, then we can conclude A is equal to B. So we can write it as A equals B. So this is the symbol for that, just a normal equal sign. Now what about equivalent set is, again we have to take two sets. Let's say we have a set C and D. So this contains 1, 2 and 3 as usual, and this contains A, B and C. Are these equivalent sets? Yes, they are equivalent sets because n of C is equal to n of D. So if the number of elements in two sets are equal, then they are called equivalent sets. They are denoted as this symbol. So C is equivalent to D. So this is the symbol for equivalent set. So every equivalent set cannot be an equal set, because these two are equivalent sets, but it is not equal sets. But every equal set must be an equivalent set. So that's the case with this. So that's the difference with these two. Now the more important concepts, subset and proper subset. So first we will see what a subset is. Now let's have A equals 2, 3, 4 and 5. So this is A. Now what is a subset of A is, we can have any set. Let's say we have A1, 2, 3. This is a subset of A because some elements in A also occurs in A1, which means some elements of A also occurs in A1, which means A1 contains the elements that are in A. So we have to write it as A1. So this is called is contained in. So A1 is contained in A, which means A1, that is 2, 3, that is 2 and 3 is contained in A, that is in this set. So this is called a subset. We can have many subsets for this. Let's say this is a subset of A. This is a subset of A. So these are the subsets of A. We have to write it as this, the contained symbol and the equal symbol, which means it can be equal to or it just contains some elements. So we have the set A. The set A is a subset of A because the set A contains the elements of A. So we have to keep two things in mind. Every set is its subset. So every set, that is A, is a subset of A. Also, 5 is a subset of every set. Because you can take an element, or we can take none of the element in this. So we can just have this. This is a subset of this. So an empty set is a subset of every set. So that's what I am meaning. So an empty set is a subset of every set, and every set is its subset. So those are two important things you have to keep in mind. So now what about a proper subset? So as we saw earlier, A1, 2, 3 is a proper subset of A. Now what is the difference between subset and a proper subset is, A is a subset of A as we seen earlier, but A is not a proper subset of A because A is just A itself, which means A can be determined or A can be calculated with A, but it is not a proper subset. So A is a subset of A, but A is not a proper subset of A. That is, let's say we have B is A, B. Now B is a subset of B, that is, and another set B can be determined by the values of B, that is A, B. But B is not a proper subset of B because every element in B is also in another element. Let's say we have C is A, B. Now C is not a subset of B because it contains all the elements of B. So this is not a proper subset of B, but this is a subset of B. So that's the difference. So now the power set. A power set is the set of sets. That is, it will contain a set of different kinds of sets. Now this is a power set. So a single set contains multiple number of sets. Now let's say we have A 0, 1, 2. This is a set. Now the power set is denoted as P of A, that is power of A. So we have a set. We have to what power set actually is this. The subset or the set of all subsets of a set. That is, what are the subsets we can get from here? We can take the null set, we can take 0, we can take 1, we can take 2, we can take 0 and 1, 0 and 2, 1 and 2, 0, 1 and 2. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 subsets of A. So the number of subsets we can get from A is 8 subsets. So from this A we can get 8 sets. So the set of all those subsets is called the power of A or the power set of A. So A has 3 elements. So how many subsets will it have? It will have 2 power 3, which is 8 subsets. So just the formula is 2 power n, where n is the number of elements in the set. So if a set has one element, or we'll have another number here. If a set has one element, then 2 power 1 is 2, which means the power set will contain 2 sets. So what are those? It will have a null set and the set we are having, that is the set of 1. So that power set, that is the set of all the subsets of a set. So the formula is 2 power n, where n is the number of elements in that set. So that's about power set, and that's the types of sets too. That's it about types of sets. Thank you.